Okay, this section is about simplifying radicals. This is actually kind of a fun section for me. I'm not sure why I think it's fun, but I don't know. We'll see. So let's say you have a radical, a square root formula that is the square root of 5 times 6. This could be illustrated as the square root of 5 times the square root of 6. It could be broken up into that way. So in the same way, if you had a different formula, or different radical, which is this is the radical sign, and underneath it's called the radicand, by the way, it's called the radicand. Let's say you had the square root of 4 times 3. What this could become is the square root of 4 times the square root of 3, which a lot of you right now are recognizing that the square root of 4, and I like to do this, becomes 2 times 2, which the square root of 2 times 2 means that the answer to the square root of 4 is 2 times the square root of 3, and you really don't even have to put that times. The answer is just 2 square root of 3, and there's your answer. So let's say that we have this, where you have the square root of 48. We want to reduce this or simplify this, and we want to reduce or simplify the radicand into its roots. So I like to play with this. I like to say, let's say, I think if you have 48, I think 16 times 3 is equal to 48. Well, I know that, this 16 can be square rooted into 4 times 4, which is a perfect square. So 16 is a perfect square. So now this 4 will be outside, which will give me 4 square root of 3 is my simplest form of this answer. Okay, hope that helps a little bit on simplifying these radicals. Now we're going to do fractions. So these two next ones are pretty similar. They're kind of the basic same thing here, but in different ways and different angles. So this case means the square root of 9 is 3 divided by the square root of 36, which is 6 times 6 is 36, which we simplify this into 1/3. And here's my answer of the square root of 9 divided by the square root of 36. This one down here, number 5, could be looked at the same way. I can break it up into the square root of 16 divided by the square root of 25. In this case, the square root of 16 is equal to 4, because 4 times 4 is 16, divided by the square root of 25, which is 5, because 5 times 5 is 25. And here's my final answer for this. Okay, there are 3 conditions for the simplest form of a radical. The simplest form of a radical. So, one of the 3 conditions for the simplest form of a radical is that there's no perfect square in the radicand. Now, there's a good example of this, is that what you can do is you can have, well, the previous example is a really good example of that. Here, let me give you another example that commonly shows up, is the square root of 12. 12 can be broken up into, 1 times 12, which there's no perfect square there. It can be broken up into 3 times 4, and 4 is a perfect square because it becomes 2 times 2. So that can't be in the radicand. And so what you do is you put the square root of that, which is 2 of 4, is up here. And that gives you 2 with a square root of 3. And that is your simplest form in that situation. The second condition is that there's no fractions in the radicand. So in this case, we need to break this bad boy up into square root of 4, square root of 16, which really becomes 2, and 4 times 4, which is simplified even more into 1/2. Okay, and the last condition, which is C, is basically that there's no radicals appear in the denominator of a fraction. So there's no radicals in the denominator of a fraction. That is not the simplest form. In this case, you'd have to go 1. And this, what's the radical or the square root of 4? Is 2, and that's 1/2. Okay, I think that covers all the ways that we can be working this. There are some tricky problems. I'm going to try one tricky problem for you. So this problem would have scared the life out of me when I was in high school, but if you really understand this, you can actually convert this part of the problem into 18 over 2 square root, which the 18 over 2 gives you 9. Square root of 9 is 3. And you can do nothing with that 7, so 3 times square root of 7 gives you 3 times the square root of 7. Now, you're going to be tempted to try to square root the 8 and then leave the radical in the bottom, but that's one of the rules of the simplest form is you can't leave a radical in the denominator of a fraction. So the best way, sometimes you have to combine them. Sometimes you need to separate them, but you need to play with these numbers. And that's why I think radicals are fun, is because you can play with them back and forth. And you need to try to work out and always look for those perfect squares. And if you have the perfect squares memorized, you don't know what to get it, or what to use.